Yeah, okay. Yes, welcome to all of you. Today's topic is design of processes. Now we have so far seen, 1 minute, I have to share the screen. Meeting is now on share screen. Okay, right. Yeah. See, the topic of session today is on design of processes. Actually, I thought this was done in the beginning of the course on operations management, but we have done only the facility layout and things like that, and not the basic design. Now, let us say that uh, any organization or any setup delivering a product or service has to undergo certain processes between the uh, input and process that input and deliver that output. That's what it means. So the process is defined as input, process, output. Now that process can be a manufacture, as in case of the manufacturing can be on different scales of manufacturing. The manufacturing can be a process manufacturing or a batch manufacturing or a job shop type of manufacturing. Similarly, in a service, there can be a service which is done on a mass scale or on a very specialized scale, like in hospitals, and many types of in between. Now, depending on the product or service being offered to the customer, one needs to design the process to suit the customer's requirement, depending upon the number of customers. Many factors are involved. Obviously, for any organization, the purpose of an organization is to make a surplus or a profit. So if the process design is done in such a way that the cost of processing the input to be given to the customer is the least, then obviously, and of course, at the least possible time and the best quality. As we said, quality, cost, delivery, service are the backbone of any operations. When that is done, then the organization is efficient and the customer is happy. So today we will take a look at all the types of processes which will be needed for different types of products and services. So that is a topic for today. Now, today what we will be talking about is what factors determine the process design. So whenever you are setting up, so this happens usually when you are setting up the organization, setting up the process. It is not just that land building and how much it is needed, but the base, before doing that itself, what type of what is the process flow from input to output? What type of equipment, what type of manpower, what type of machinery, what type of facilities are, how much power that is needed, what type of energy, many things are taken into account before you decide that this is how my process design will be. And based on that, the space needed to accommodate that. Of course, again, before that, you need to know what is the layout of the process, what are all the things that is needed, and the space that is needed. and then plan the facility in terms of the building and other power, water, steam, gas, whatever that is needed for that particular process. Right. So this is the first thing what you do whenever you design, whether in case of a manufacturing, in case of a hotel, in case of a hospital, in case of a bank, for that matter, any kind of operations. What factors are determine the process design? How process choices and flow characteristics of jobs are linked? Well-known process design options. We'll see a few of them. Process design in service systems, because today there is no many of the services are actually the products on the one end, services on the other end, products and services together. All three are there. New technology which is used in process design. As you know that there is more and more of automation that is happening, more and more of new technology that is coming in. Like you must have heard of 3D printers now being used extensively. So there are new technology, and then now we are talking about artificial intelligence, Internet of Things. We talk of machine learning. Many of these technologies are used in manufacturing, and alternate planning methods related to the process design, complexity of operations management. One sec, okay. Complexity of operations management. All these will be discussed in today's topic of design of processes. Design of processes essentially means various choices that we make with respect to the flow of parts in a manufacturing system or flow of sub-processes in a service system. Design issues set the overall constraints within which operational control systems operate. Well, like when I say a design issues, now you can say that, in a process industry, you have a fully automated process, but you could have a semi-automated process or a fully manual process, depending upon what you want to do. It is like, let's say even things like detergent manufacturing. Okay, a detergent manufacturing is a fully automated process when it comes to surf and other, big people. And there are many small self-help groups which make in semi-urban village areas, these kind of products where it is fully manual. So from on the one extreme, so what kind of process we adopt will again determine the kind of subsequently the facility and other processes. Factors influencing process choices. Usually there are three important aspects. One is the volume. You see how much you want to produce. See, like we talked about this example of detergent in a mass scale. Obviously, they will not be producing 10 or 100 or 1,000 packets in a day. Probably it will be some 100,000 packets in a day of different 500 grams, 1 kg, 2 kg, that kind of thing. Maybe not too many variety, but very high volumes. So what is the volume which you want to? Depending upon the volume, then the capacity of equipment and machinery that are needed in each of the processes, which start, from the start to finish, that has to be designed to ensure that there is a throughput with the least amount of material in the pipeline. In case of low volume, see, it can be, again, volume can be low volume, like in case of turnkey projects. See, it's like uh, uh, putting up a plant by L&T, let us say. Now, that is a one-off thing, and it is based on that particular design. It is not going to be repeated anywhere else. So in this, for doing this, the process design will be entirely different. In case of high volume, consumer, non-durable, and FMCG, like we talked about soaps and other things, it could be automobile, chemical processing. Now, in these cases, the process design will be again entirely different. And you have mid-volume, certain white goods which we see. Now, the volumes are not very high, but at the same time, it is, you can say, semi-mass produced goods. And many of the industrial products which go are B2B industrial products come under this category. So one was the volume we saw, either it is a low volume, high volume, or mid volume. Other is the variety, the number of alternative products and variants of each product that is offered by a manufacturing system. The product may look same or similar, but the variety which is that is needed by the customer, or the what we call in retail terms called the stock keeping units or SKUs, may be different. In which case there may need to be, in the course of manufacturing or production, you need to keep changing the setup, and that is where, if in the we talked about the single minute exchange of dies in the quality session, that comes into the picture here. Maybe that there are the different variants are produced for each product on a given day. So you need to plan how to do that and do the setups. So the first one was a volume. Second is a variety. So the variety of product offerings is likely to introduce a variety of various processes in the system, alternative production resources, materials, and skill of workers. Sometimes the materials may also be different. Thirdly, you have the flow indicates the nature and intensity of activities involved in conversion of components and material from raw material stage to finished goods. When we say flow, just think of, let's say, petroleum, from crude to making petrol, diesel, kerosene, basic variants which come out. See, these kind of plants run 24/7. There is a continuous work. Or if you say, let us say, steel manufacturing. See, once, steel plants, they cannot even afford to close down for an hour. It's like it works 24/7, 365 days. And if they take a shutdown, that means that furnace has to be shut down, and restarting the whole process will take enormous time. Same thing goes like if you've seen a paper mill, it runs 24/7. At least in some of the mass production kind of thing, unless it is a specialized papers. Whereas if you're talking about mid-volume and low-volume production, there is the flow will keep varying depending upon the product variant which you are producing. And so the flow depends upon the activities which are the intensity of activities that is involved. That can keep changing. So the three important aspects of any process design is volume, variety, and flow. Now, a simple diagram like this, on this side is a volume, on this side is a variety, on the left side is a volume, this side is a variety. When there is high volume and low variety, see, when there is low variety and high volume, like in case of petrochemicals, even automobile manufacturing, of course, at the final assembly, you'll find that usually the assembly lines are one assembly line produces one type of vehicle. And that usually doesn't change frequently, not at least on a shift to shift basis. It may change on a day to, after 2 days, 3 days kind of thing. But this, the line setup is set up to continuously produce the same thing over again. There are many mass produced goods which you see today, which usually like process plants like petrochemicals, yes, it produces the same thing day in and day out, day in and day out, kind of thing. So high volume, low variety. Then you have mid volume, mid variety. We saw about here motor manufacturing. In fact, I used to work for this company called Crompton Greaves, who make motors. We make right from 0.25 HP to 100, 500 HP motors. Now the line is not designed that, you don't need, let's say, a 100 HP motor in hundreds and thousands. They're in lower volume. Whereas like a 3 HP motor, which is very common, is produced in large volumes. So you could have a specialized line for that high volume thing, but for mid volume and mid variety, you keep changing the line, production line, based on the requirement of the by the marketing and the customers. Pharmaceuticals, basically, if you see one company, take any company, like the other day I was looking at, say, Torrent Pharmaceuticals from Gujarat. The number of variety they produce, and it is not, you have to clean the entire system before they start doing some other formulation. There are literally hundreds of different types of pharma products which they do in different concentrations, like 1 mg, 10 mg, 50 mg, that kind of things, and in different packagings, different combination of the drugs which are there. So there is a mid volume and mid variety, and of course they are not producing unless you are producing like a Discrete or something like that. We have Reckitt Benckiser in Mysore, which produces Discrete. That is mass produced a single product in millions. But otherwise than that, most pharma companies have mid volume, mid variety productions. Then high variety and low volume. Now, this is where you have project organizations, turnkey project, and people who make special purpose machines, let us say. Now, you can even include hospitals in this, because the variety is limited of services which any hospital provides, especially suppose, let us say, a heart specialized in only in cardiac. But the variety is limited, but and each customer, each process is different again, depends on the customer. So it ranges from high volume, low variety to high variety, low volumes. Processes and operation systems, alternatives available are the process characteristics are largely determined by the flow of the products in the operating system. 3 types of flows occur in an operating system. Now, we saw that that continuous process or continuous flow. I'm reminded of somebody saying that machine mein ek side mein you put something and something comes out, you know, uh, in a lighter vein. So it is like this, that you put something here and the output comes. Usually happens in paper process industries. Paper, you know, that it is ultimately made from either mostly from wood, different types of wood, bamboo, and of course, recycled paper uses the already used paper. It flows through a distinct processes one after the other. And if you see the final paper drum, which where the paper comes out, it is just doing, you know, reeling it out continuously, because most of them are high volume productions, process industry. As I told you again, steel manufacturing, it is totally process. You can't even close down. So mass production, discrete could be high volume, low variant, like spark plugs. Of course, now they use different technology. Electric bulbs, of course, today all are even CFL is outdated. Now you have LED bulbs. Of course, producing the same technology, the same bulb. At the most, what is a variant? It will be a 9 watt, 14 watt, 20 watt, that kind of bulbs. That's all. So hardly any variation, but the same thing. Hundreds and thousands of bulbs are being produced with very low variants. Here, either it is process or discrete. So this is the difference between the thing. There is a continuous process, closed loop, or discrete manufacturing. Intermittent flow happens when there is a mid-volume, mid-variety, where capacity estimation is very complex, because let us say I talked about this motor manufacturing, 0.25 HP to, let us say, 100 HP motors. It is not that producing, or say like 1 HP to 100 HP. It doesn't mean that, you know, producing 100 1 HP motors equivalent to producing 100 HP motor. No, it is not. So estimation of capacity is very complex. Sometimes what we use here, like what I used to do, is break it up into 2 or 3 categories, like let's say 0.25 HP to 3 HP or 5 HP, then above 5 HP to let's say 50 HP, and 50 HP above 200 HP or more. Then you can do some kind of a capacity estimation, because you can normalize some of these varieties to estimate how much you can produce with the existing facility. Then you have a jumbled kind of a flow, because no two processes will be the same. Each one will be different. Simple thing to look at is a printing press. You know, even I'm sure you must have accustomed to going and getting some even an invitation printed or something from your local printing press shop. Now, he has certain processes. Now, not everybody wants the same type of card. Like even for a birthday card or a wedding card, if you have gone, each one wants a different type of a card, different type of a typeset, and different type of a cover. And some of them may use certain special equipment for doing it. That is something which we all have gone through sometime or the other. Printed circuit boards, those of you who have been used to electronics, that this is basically comes under the electronic manufacturing services. You see, nowadays it is the tier 3 of electronics is the electronic manufacturing services, who makes these PCBs, PCB populating, and each customer has a different PCB different complexity, right from single layer. Of course, single layer nobody does today. Multi-layer PCB boards using different set of components, different everything, and different volumes. Some of them may be mass, some of them maybe just 10 pieces. So there is a customized manufacturing system in this, and we normally call these as job shops. Job shop, because you get a job, you produce according to what it wants. Like other extreme, we talked about printing invitation cards kind of thing. PCB in manufacturing, again, PC manufactured to the next day. It may go for a automobile manufacturer. A PCB may go for an instrumentation. It may go into telecom. May go to defense or even the space. Because even ISRO in a rocket has many circuits. Now they don't make that. They outsource these to some of the companies which make it. So, but then you don't need to make 100, because after all, only a few of them are needed, but then they are highly specialized. So the customized manufacturing systems or the job shops. So the three flow types are continuous, incontinuous, closed loop, and discrete. Intermittent, which caters to the mid volume and mid variety, where estimating capacity is difficult, but you can break it down into smaller groups to estimate. A jumbled process, which can be project organization, which is a one-off kind of a thing, or customized manufacturing systems, which are called as job shops. There can be many examples for this. Usually it is B2B, or unlike in printing, which is a B2C. Okay. Continuous flow systems are characterized by a streamlined flow of products in the operating system that we saw earlier. Now we'll go a little more into the detail. Conversion process begins with input of raw material at one end, progresses through the system in an orderly fashion to finally become finished goods at the final stage. In this, the layout, everything is predetermined. Like in Mysore, I've seen the Nestle plant, which makes coffee, right? It is right from the time when the berries are fed, the coffee berries are fed at one end, to the final, with the coffee powder, which is again packed on the at the other end. It is a full continuous flow. There is no stoppage or taking the material from one place or putting it into the other. The process is continuous. The material flow is continuous. There is no or very little storage in between the processes which happens. It is a continuous thing. So conversion process begins with the input raw material at one end, progresses through the system in an orderly fashion to finally become finished goods at the final stage. Production process is sequential, and the required resources are organized in stages. This is very easy. It just one process gets over, and then the material, either in a liquid form, powder form, gas form, whatever it is, goes to the next process that gets worked upon and goes to the next. For example, several chemical processing industries, such as manufacturing of petrochemicals, steel, pharmaceuticals, usually formulations, now the basic drugs, which thing, cement, glass. Now, these kind of things are continuous process, and you don't stop any of the process in between. You cannot stop any of the processes in between. And that is where the challenge lies in this continuous process plant. In a discrete manufacturing industry, high volume production of very few varieties, such as bulbs, spark plugs, as it says, there are many, many examples for that. Like even if you see the battery or our everyday batteries, we have a plant on the way to Bangalore, which I've been there, that everyday. They mass produce these AA and AAA batteries. It's several millions are produced every day. That is a discrete mass production. That is the process from one stage to another. The material moves in probably in conveyors, and people work on one thing, go to the next, which works on something and goes to the next till it is finally given, fed to the packing machinery and taken physically and packed in cartons and things like that. Similar thing will go on. Let us say our many of the items we use on a daily basis, Tetra packs or those kind of food packed items. They are all basically mass produced process items. So, like in case of we talked about paper manufacturing. You see, basically we all start with logs and chips of wood. If any of you have seen any of the paper industries, quite nice to see. We have a number of such units. In fact, ours is called a paper belt between Mysore and Nanjangud. There are many number of paper industries. And paper, you need a lot of water. You can put up a paper only near a river or something like that. So it needs lots and lots of water. Crushing of logs and chips, processing of wood, cleaning and bleaching, because all this needs water. Refining the wood pulp needs a lot of water. Drying, then of course, the drying the wood pulp, stretching the paper, the huge drums which are used, for rolling the paper, depending upon the thickness of the paper that is needed and what type of paper. All this will be determined, and then finally cutting and final packing. It is one flow. Up to a certain point, it is a continuous flow, and then you have discrete flow. Now, this is a very complex operation. Those of you who know, of course, Reliance, Dhirubhai Ambani saw that when he first set up the plant in India. He knew that the continuity of the process has to start from oil and gas, and then to polymer and chemicals, refining, then polymer and chemicals, and from there it goes on right up to the textiles which they produce. That is their continuity right through, and the main products and byproducts of each are used in the next process. Now, to minimize the storage and movement of these products, they have plants which are one dependent on the other, and one byproduct is a input or a raw material for the next product and that factory. So similarly, like if you see here, from the oil and gas which comes out from the wells, oil wells, the refining is the first stage, the refinery, oil and refinery. Of course, they have in Hazira, I think there are many other refineries. Now, the output of the oil refining is basically gasoline, diesel, and ATF, or the one kerosene which is used in aircraft for flying. Then other products, other byproducts are the naphtha, liquefied petroleum gas, sulfur, fuel oil, bitumen. All this comes out of the thing. Some are directly sold to other processes, and some, as you see here, these are all sold, goes directly to oil marketing companies. Reliance themselves market, but then it is also to the other oil marketing companies like BPL, Indian Oil, and HP. Whereas the LPG and naphtha is used, goes to a cracker plant in Hazira, from where the products which come out are again all these. Some of them go directly as a direct product, and some again are raw materials to the next process. Like from here, if you see, one of the things which come into the propylene. Now propylene is taken to the next stage to polypropylene, which is what you know. Similarly, here, the byproduct for this, if you see, is also some of these, including PVC, what you see. So polyethylene on this side. You may need other inputs for the different processes. And one more plant uses some of the outputs from here, like the xylene and these, to produce polyester resins, polyester chips, which are used for, again, plastic parts and moldings and things like that. And from polyester resin, again, you go to making your polyester fabrics blended with other wool, silk, cotton, all that kind of thing. So there is a textile plant which goes in Naroda. So if you see, there is a continuous process, which each one depending on the other, that is happening here, all starting from the base of oil and natural gas. Right. So what are the issues in such kind of a process industry? See, the flow rate determines the capacity, in the sense that how much throughput that can happen is determined by the bottleneck in the system. It is like, if you see in your own house, in the taps, water is flowing. If there is a constriction or a blockage, then the flow becomes less. If you want to increase the flow, you have to clean the bottleneck and make sure that the flow is higher. Similarly, in the process industry, now you cannot push more to get more output, because the bottleneck will determine what will be the throughput. Similarly here, if you want to increase capacity, you have to keep determining where are all the bottlenecks and increase the flow rate in those bottlenecks processes. Nature of inventories. Now, in such process flow, work in process is something minimal, because the end of one goes directly to the starting of the next process. So there is hardly any inventory. But the inventory of spares and maintenance will be very high, because you cannot, as we said, we cannot stop any process because of malfunctioning of machines. When you stop that process, the entire process going forward and sometimes even backward, everything stops. So to ensure that, there'll be alternate machines, there'll be spare parts which is kept ready to ensure that moment there is something going wrong or likely to go wrong, you immediately ensure that it is set right. So you need to keep very high number of spares and maintenance staff and maintenance through monitoring these processes. If you see, they are huge consoles continuously monitoring what is happening, and which is also what we call in electrical parlance, we call it annunciation. Annunciation is something where when something is like, let us say, a pressure or a flow or temperature or viscosity, any of the parameters, if it is above or below, just like in your case, like today, when you go anywhere, they test you for that COVID, your temperature should be not more than 100 degrees Fahrenheit. 98.6, okay, 99 be chalega, but the moment it goes by, that means that could be an indication that you are there, no kind of thing. Similarly, your SpO2 or oxygen saturation level should be at least above 94, kind of thing. These are nothing but annunciations. Now imagine we are only talking about 2 parameters. Like in a process flow, there may be hundreds of parameters and which are being monitored. And the moment something goes wrong, some process, some machine, something is malfunctioning. So that is being monitored 24/7. Imagine a nuclear power plant. And if you have seen that movie of Chernobyl, and of course, we are again talking about Chernobyl now with the war going on between Russia and Ukraine. And one of the things which they are trying to safeguard is Chernobyl, where again the nuclear power plant is there. You cannot afford it for the nuclear runaway to happen, which happened in Chernobyl many years back, and it affected the entire Europe, the northern part of Europe. So they have to continuously keep monitoring and making sure all the machines work. And so you need high level of maintenance and spares for the inventory is mostly only in that and not in the process. Importance of maintenance, that's what I said. Relevance to vertical integration. Joint and byproducts are many. Exploiting process opportunities of this are important. Otherwise, of course, you'll be selling them as products to others to manufacture. Whereas it makes sense if you can convert that into each of the byproducts into a finished product, wherein you get a more value add and they are marketed in turn. And that's what Reliance does, Now, continuous flow systems in mass production in discrete manufacturing. We saw that was a continuous flow manufacturing. This is in discrete manufacturing, various components are manufactured in discrete fashion and the final product is obtained through an assembly process. Simple example, like you talk about cars, of course. In cars, the final assembly, you may be producing one model of one particular car in a day, or the same thing produced at least for 1 week, and in one of the lines, another line produces something else, etc. It is mass produced, but at the same time, of specific models and specific gaps, like in the example of motors, which I talked about, from 0.25 to thing. There are discrete manufacturing. Some lines are mass produced, some are smaller volumes with specialized production things. So here in discrete manufacturing, various components are manufactured in discrete fashion. Now, when you say manufactured in discrete fashion, it need not be that it is done only at the stage where the final assembly is done. Sometimes what happens, the manufacturer may have their own facilities in some other place, or it could be outsourced to subcontractors. Like we talked about business process outsourcing, right? Or to their ancillary or units, or to others who manufacture. Like in a automobile, the brakes are not made by, brake and brake assembly usually is not, the mostly used are from Brakes India, which is a TVS group company. Similarly, there are different, the clutch plates are from some other place. The axle is from, maybe you may produce, or you may subcontract it to somebody else. The electronics and harnesses, as they call the electrical wiring, everything comes ready-made in such a way that they directly fix it. They don't do it anything on the thing that is called a harness. So like this, the discrete components are manufactured at various places by the company or from other outsource companies, and then come to the final assembly in a discrete mass manufacturing. In mass production system, the volume of production is very high and the number of variations in the final product is low for a given point of time. Right? It can be, it can keep varying, like in the models in a car or something like that, but it's not so high as you can see in many other things. But like in pharma formulations, as you said, there are hundreds there. For example, automobile and two-wheeler manufacturers. manufacturers of electrical components such as switches and healthcare products such as disposable syringes. They are all mass produced. Variety is very less. Same thing is produced more and more. Today, of course, the masks you have and gloves, many products which are they're mass produced. The entire manufacturing is organized by arranging the resources one after the other as per the manufacturing sequence. Here, although the difference between the discrete manufacturing and the continuous manufacturing in case of the process is that in process there is no storage of material in between processes. It is flowing continuously. Very little storage is there or no storage. Whereas in discrete manufacturing, after every process, there will be a certain amount of WIP before it goes to the next process. So the total WIP, if you take, let us say there are 10 processes from one end to the other, and the production, let us say the flow is 100, say, units per hour. Okay. It is not that each of these 10 processes between 1 and 2, there will be some material produced by 1 waiting for the 2 to take up. Like that, there will be WIPs or work in process in each of the stages, unlike in a pipeline continuous flow system, which we saw earlier. This is an example of a process design for mass manufacturing. In this, you see that the machineries used today, of course, in most of them earlier, it is just not simple. They are all called what we call them as SPMs or special purpose machines. It could be that lathe, drilling, all that kind of machinery, but each are made or fitted or programmed for specific jobs. So it could be, the processes could be machining, fabrication, assembly, testing. This is a typical kind of a thing in any manufacturing line, but dedicated to the different products which are produced in that. So this is mass production, but discrete. Then we have intermittent flow systems, which are characterized by mid-volume, mid-variety products, which we saw in that earlier example, that curve which we saw. Increases the flow complexities because the volume, flow, variety all keeps changing. Now, flow and capacity balancing are difficult but important. Process industries use batch production methods. Discrete industries use alternative methods of design layout processes. See, typically, we used to manufacture some electronic components which have basically, let us say, 4 basic varieties, but hundreds of sub-varieties. That is what we used to do in our component. Now, the basic processes remain the same. So we have dedicated lines for certain sizes, but many of the other processes are common. So balancing lines become quite difficult in these. And but that is what the production planning and control job is, to take care of this flow balancing. Capacity estimation is hard. You can't say that. I would rather say it should be the unit value of a product multiplied by the volume produced that particular day. That will probably will have some bearing on the capacity rather than just physical volumes in terms of numbers or liters or kgs or whatever it is. Depends. Production planning and control is complex. As I told you about before, it's a job of PPC to line balance the whole operations for that particular day. So process design, for intermittent flow in discrete manufacturing, as you say, there are different operations which are happening, different parts which are happening, and different types of assemblies which are happening all the time, depending upon the customer orders or customer requirements. And you manage the usage of equipment and manpower based on the jobs that need to be done that way. Intermittent flow systems, the problems, if you have a bad choice of structure and the correct people are not available who have the required expertise for those particular jobs, then you land up with complicated material and information flows, thereby making production planning and control complex, which demands special mechanisms to bring order out of chaos. It is very easy to get to a chaotic situation in manufacturing, especially when you have such job order, intermittent flow system kind of thing. In fact, in my own plant, which has some of these complications, we used to dedicate one senior person who's just only constantly looking at production planning and making sure that there is no bottleneck of either material or machine or manpower at any given stage. That is the thing. Special mechanisms to a lot of paperwork is needed, of course, planning, enormous supervision, coordination, progress chasing, expedition, because you need to know at what stage, what product, uh, which order, where it is lying, etc. Long lead times, unwanted inventory because you gather to make up for the shortages, high overhead costs, etc. Lastly, we have a jumbled flow system, or what we call as again a job shop kind of a system. Occurs on account of non-standard and complex flow patterns, characteristics in highly customized items. Customer orders are one or a few. See, it is like we are talking about rockets. If they are making rockets and then they subcontract these orders, they are not going to give for 100 rockets or something like that. They may give one or two or maybe 10 at the most, kind of thing. And highly customized items because it may need special treatments of materials, special machining, special testing, etc. Like examples, turnkey projects, customized manufacturing as in PCBs, sheet metal fabricators, printing and publishing at the other end, which we saw. Operational complexity arising out of jumbled flow is very high. Discrete manufacturing with jumbled flow uses job shop structure. As I said, jumbled flow system is nothing but a job shop. So this could be like, some of the material may flow from here to here, but then some may flow from this to this, then go there and then come here. So there is a totally jumbled way of material flow for different orders, not for the same order. The same order repeats, then the flow will remain the same. But it doesn't happen. Different jobs come in which needs different processes, and so there is a flow which takes place, and there is a chaotic thing. So you need a lot of planning and monitoring in these cases. So complex issue is capacity management. Considerable time is lost due to repeated setup of processes. Problems are often hidden and built up of work in process inventory takes place. Cost accounting and estimation systems are crucial. Now, this is one chart which gives a total overview of what are all the characteristics and what kind of issues are there in continuous, intermittent, and jumbled, as there are three different flow characteristics. And types of production. In case of continuous flow, where there is a high volume, low variety; intermittent systems, mid volume, mid variety; jumbled systems, high variety and low volumes. Similarly, production system, usually there's a process industry or a discrete mass production. Intermittent can be batch production in process and discrete manufacturing. This is a project organization, tool room, or general purpose fabrications. Issue of importance, like in continuous flow, flow balancing is extremely important. Maintenance is extremely high requirement. Capacity utilization and debottlenecking is very important, because a single bottleneck can choke the flow of the entire line. Backward integration is needed for all the materials here. What to do with the next process? What do you do with the next material or the byproduct and all that kind of. Intermittent flow, the manufacturing system and layout design, changeover management is very important, because constantly the line requirements keep changing, and capacity planning and estimation is difficult. In jumble, capacity estimation is most difficult, because sometimes it may take very long. It can be depending upon the number of processes that need to take place. Scheduling is very difficult, and cost estimation is again very difficult. Operation and management tools and techniques. These are all the techniques which can. Line balancing is one of the most important. Maintenance, and both preventive and breakdown maintenance, that is very important. Process optimization, product layout design, flow shop scheduling, full type of scheduling, single piece flow design. Here forecasting is here, capacity planning, etc. Materials management is very important. Of course, you have WIPs in this process. Here, it's a project management and scheduling is the most important here. Capacity planning and optimization. A functional layout design. See, basically in layout design, if you see that it could be a line design, it could be what you call as a functional, a group wherein the entire process happens one after the other. Within the, for small volumes, and then remove that layout and do a different layout for a different product. It could be that kind of a thing. So job order costing is very important in this, because otherwise you can go haywire on costing. Well, here in this is a simple diagram which tells you about the product and process, where the low volume, low standardization, and a single products like here is done in a job shop situation. Multiple products, low volume, like in machine tools, use this discontinuous line flow or batch process thing. Few major products, higher volumes, use assembly line systems here. And high volume, high standardization or commodity products, as they saw, like petroleum, diesel, they're all what we call, or polyester fiber, even fabrics for that matter, everything they're called commodities. They are use a totally continuous flow system. So this matrix very clearly explains, very simply, whatever we have done so far. Yes. We will take a short break. Okay. We've just done about an hour, and we'll now talk about the service systems. We talked so far about all manufacturing systems. Service systems, like in hotels, hospitals, you can think of many areas. We could even discuss some of them here, and we can interact. So we'll talk about that the second half. So there's a short break. So my watch says 7:01. So 7:06 we will get it. Okay.
Okay, sir.
Time out. 5 minutes. Hello. Yeah, we will now continue on the process design issues relating to service systems. Now, what is distinct between a product manufacturing and service? When we make, let us say, a car. Yeah. Yeah, Sashiji, you want to tell any inputs? You have unmuted. Okay. See, the difference between a product and a service is a product need not be aimed to for a particular customer, or not at the time of manufacturing. It is not going or to the customer directly. Like in case of you, when you produce an automobile, it does not know whether it is going to Sashi or Meghna or Anshaj, or for that matter, anybody in this country, right? Whereas when you talk about a service systems, like in case of a hotel or a hospital, it is the closeness of or the linkage with the customer is direct. So a customer contact is what signifies the extent to which the customer participates in the preparation and consumption of service. Ultimate, as you can say, is a hospital. In a hospital, of course, you will say, how does the customer participate? Because the customer has to be there physically. No, he cannot be. There cannot be a proxy like in somebody else substituting for that customer. And the customer has to cooperate with the medical, paramedical, and all the people, either the customer or the customer's representative. Could be the son, father, husband, whatever, whoever is their caretaker. And so there is a customer participates in the preparation or consumption of that particular service. The nature and intensity of interaction that the customer has with the entities and service personnel. For that matter, anything, like even if you go for a bank, like, so obviously when you go to a bank, you have to interact with the cash clerk or the officer or the somebody who's doing your passbook, or where you inquire for a certain type of fixed deposit or a savings account or an FD account, that kind of thing. If you go to a hotel, somebody has to guide you what is available, what are all the varieties of things which are available, what are the specialities today, let us say. Many things you ask before you order what you want. And sometimes even in the order, you say that I want less of this or more of this, and I don't want this, that kind of thing. So there is a intensity, nature and intensity of interaction with the customer has with the entities and the service personnel is high whenever there is a service system. The level of exposure that the customer has of the various facets of the service system while the customer is receiving the service. In fact, if you see in, I don't know, in especially in Bangalore and Karnataka, we have a lot of these hotels which give, which have literally open kitchens, kind of thing. And they are mass producing many items continuously, of course, but based on orders. They are, of course, we call them darshinis, that is right through the day. You get from morning, they start from around 6:30 in the morning to about 10:30 at night. Continuously, hundreds of customers are flowing around that, darshinis or tindis, we call it, here, And you can custom make whatever you want, even after you take, even if you go to your dosa, you don't want this, you don't want that, or you can add this, or how strong your coffee should be, that kind of things, This is what is difference in between the product and service. So the level, whereas when even when you order in a Swiggy or Zomato, you can give instructions to them what special instructions that you need. The level of exposure that the customer has of the various facets of the service system while the customer is receiving the service, that is important in it. That is a characteristic of a service system. Degree of complexity refers to the steps and sequences in the process measured by the number and intricacy of steps. Usually in service systems, various types of services are offered. Like in case of a restaurant, uh, some of them may be only, let's say, multi-cuisine, could be only vegetarian, but have South Indian, North Indian, all that kind of thing, facilities, or Rajasthani style thing, all kinds of could be. A hospital could be a specialty hospital or could be a general hospital. Similarly, a nursing home, a insurance company can be dealing with only life insurance, or it could be a general insurance. Banks having multiple products. So the complexity refers to the steps and sequences, the processes which are done for each of the products, and the customer requirements may be very different. That's what this happens in a, like in a hospital. A patient comes, can have 100, any particular kind of problem, or if he's an accident patient, he could have multiple problems which need to be attended to. Degree of divergence indicates the executional latitude and variability of these steps and sequences. Like two people coming with the same complaint in a hospital, let us say, need not have the same problems, and you can't standardize the process. It can vary depending upon the variability of the parameters of that particular patient itself. It could be age, male or female, right? The body mass index, many things which are taken, the patient's history. Is he a diabetic, not non-diabetic? No. So that degree of divergence indicates the executional latitude or variability of these steps and sequences. So each person's case is different. So customer contact, degree of complexity, degree of divergence, all three influence the service process design. Degree of customer contact. Now we just take those three things which we saw individually now. Design implications. Low customer contact can be quasi-manufacturing, in the sense that most of the things are kept ready, and only when at the final stage, when the customer is in contact, you bring in the processes and give. This could be even, we could talk about standardized items of consumption. Like if you take a pizza, okay, let us say a pizza. Now there are three types of pizza bases at the most. There may be toppings, maybe 4 or 5 different types. Now it doesn't mean that the person, they start manufacturing from the beginning. It is just that most of the things are standard available, and the moment the customer specifies something, the quasi-manufactured items which are there are all put together. That is why they say that you can from the time of ordering to you are receiving, you will get it in less than 30 minutes. Otherwise, it is not possible. Medium, there is a mixed service. Like when you go to your fine dining, the same thing cannot happen, because you are ordering specifically items which are needed, are not again exactly put together, but then some of them are made from certain basic material. Pure service, like as in a hospital. Hospital is a pure service. No two cases are the same. Everything is different. You have to understand the patient right through the full detail, and then decide what is to be done, and then get the service done. Implications: efficiency of operations, capacity decisions, facility location choices. Like let us say a very simple thing. In case of a operation theater in a hospital, how do you decide the capacity? Can you say for sure that we can do 10 operations per day? I don't think you can, because there are sometimes when operations, when they start, depending upon the complexity, what could be a 1 hour, what you think normally could be 1 hour could take even 10 hours. So there is no way to determine a capacity in some of these kind of cases. Facility location choices, control of operations, efficiency versus effectiveness. So tabulation, when you put, this is something taken out of for the eatery, because that is easy to understand. In case of restaurant, low complexity and divergence. This is what I told you about our darshanis in, I don't know the equivalent what you have in the north, but this is very popular here. That especially in places like Bangalore, the amount of people who eat out, I think, are probably the maximum, because the floating population is very high therein. So if you see typically a darshini or a dosa point or whatever it is, you will literally find hundreds of people, and there are even in one area there'll be about 10 of them. These places working, they can't afford to have too much of variety in the menu. Of course, as you say, idli is idli, dosa is dosa. There's standardized many things kind of thing, and people do. So there is no reservation. There people come, they buy here. Usually they buy a token. They go to the counter and say what they want. Invariably, most of these places do not have even a table and chair to sit. They just put some standees outside the restaurant where you just put your plate there, and about 5-6 of the people are standing around and having the food, and nobody knows the other person. No, you just eat and take the plate, put it in the thing, sink, and keep going, moving. Very high turnover of things, like self-seating. Nobody tells you that you can, meaning you go sit here or stand here, that kind of thing. Okay, so these are all the choices of orders. Less, see that, like as I said, only South Indian vegetarian. Usually in these places you get, and he will say very specifically, this is available up to 10 o'clock or something. So after that you will get this. I don't know whether if you have heard of a place called MTR, Mavalli Tiffin Room, or which one, very famous. It has a lot of fix. They used to have that between 6 to 8 o'clock. 8 you get idlis, from 8 to this you will get this. It's a very high turnover kind of thing, and there are many such places. So low complexity, high divergence. This is one way of organizing the service. Could be a reservation kind of a thing, where you go to any restaurant, you get in, there is a person usher in. Either you do the reservation before, or you go there, he will tell you where you can get a seat, or ask you to wait till you get a seat, and all that kind of thing. So this is a semi or a thing, in a very fine dining kind of any or 5-star kind of hotels. You don't go there without announcing. In fact, you book the table before, and the person taking the order tells you what are all the things which are available. Apart from showing you the menu, recommends you what are the things you can have, the today's specialty or all that kind of thing, and many alternatives to choose from. Okay, these are all the different, from low complexity to high complexity. There are different types of process design you can have. Service process matrix. On the horizontal, you have the degree of interaction and customization, and here you have the degree of labor intensity that is needed for. This is low, high here. Low degree of interaction, and low degree of labor intensity. Usually, some of the low-cost airlines, Indigo, of course, now Air India has come out of that and it's taken out directly. Go Air, many of them are there now. Trucking industry, where there you hardly have any interaction with the thing, only at the beginning and end, and in some kinds of hotels, a very high degree of interaction where you have in the services like in hospitals, repair services, automobile garage, where you sometimes stand and see what the person is doing and get it done, and instruct him also, the person. Okay, so spas could be in this service shop. There are many areas where you can include this high interaction and low intensity. Mass service, where there is labor intensive, like in schools, wholesale retail businesses, and where high degree of professional service, which is there, where you need expertise of people, and you go there only specifically for that. Doctors, medical care, legal services, many other things, interior decoration, you can call of anything where you have personalized professional service, which is there. So this could be some kind of a, you can classify things what you do according to this. There is another manufacturing system, type of manufacturing now we call as a flexible manufacturing systems. See what has happened over, let us say, over the last 30, 40 years. Whenever we talked about manufacturing a part, a complicated part, it could mean that it has to pass through different stages of, let us say, the lathe machine or a turning machine or a drilling or heat treatment or tapping. There are various operations in machining. Then came these machines then started becoming computer numerically controlled, or what is called as the CNC machines. But still discrete operations one after the other. Then came what you may think of as maybe robotic operations or flexible manufacturing systems, where you can, for a given complex part, the entire part is done in one station. You just load the part and suppose even if there are 15, 20 operations, they are done one after the other in the same machine, which is fully programmed and done one by one, and then the final part comes out. These are basically, these kind of flexible manufacturing system, or FMS, is predominantly used now in almost all kinds of production, and more in automobiles. It could be steel parts, it could be aluminum parts, it could be a composite material, whatever they are. So a flexible manufacturing system is a system consisting usually of numerical control machines. When we call numerically control, computer numerically controlled machines, connected by an automated material handling system. Nobody handles the material in between. It is loaded initially, and then the material handling is done by the machine itself from one operation to the next operation. That is what you call as a robotic handling, operated under a central computer control, a program capable of simultaneously processing a family of parts with low to medium, with different process cycles and operating sequences. It is an attempt to solve the process complexities arising out of mid-volume and mid-variety parts. I'll just give you an example. Like if you see here, these systems may look, it is not that this is they are specifically made for making specific parts. high volume parts, and programmed for making those parts. One such example is this. One such example is this. This is the company which makes that KTM, something as you see here, Flexomatic FM100, he calls it, which is this. This is another machine. You can see a conveyor kind of a thing going also, where the materials are loaded from one end, does the complex operations, and then comes out. I have given couple of examples here. These are the kind of parts which usually are made by these machines. Now, this could be a part in some assembly in some way going into some vehicle. This may be some part again in some other machinery. You see the complexities. Earlier, for doing one operation like this, you needed one machine doing one operation, then you physically change it and load it onto the other place. So there is a setup time. That process, like if you see here, there is a hole which needs to be drilled and then a thing trapped, etc. So this entire part is fed, the raw material is fed in one end and finish and comes out on the other. And this is programmed to make this particular part. So that is why it is, and it is flexible because the same machine can do different types of parts. So this is why they are called as flexible manufacturing systems, which are integrated CNC machining usually. So structure of a machine, there is a system controller, there is a loading unloading, which is the only manual part of the whole thing. Then there is a primary material handling system. There is a secondary material handling system. Then the machine tools which automatically are put in and taken out and all that. And auxiliary equipment like pneumatic gas, could be water, cooling fluids, all that which is there. From the system controller, the thin lines are the information flow, the thick lines are the material flow, and then the finished part comes out. Flexibilities in this, which is now, as I told you, these are very commonly used today in many of the mass-produced items. Flexibility, more than anything, what is more important to understand in any process design is that if you are looking for quality, then you can get quality only when you have consistency in production. And you can have consistency in production only when you are able to automate. The more you automate and the more you monitor using statistical process controls, the more consistency of the process and much tighter tolerances will happen. So the more you automate obviously means that you make the combine various processes, and that is why you need these flexible manufacturing systems. So machine flexibility, the ease of making changes. So why is it FMS? One is the machine flexibility, because it is not made for only one part. It could be a family of parts, and those changes in those settings can be done. Process flexibility, product flexibility, said a family of products, different types of products, as you saw in that thing. Routing flexibility, that in case of breakdowns, it goes to a different type of products, that kind of thing. Volume flexibility and expansion flexibility. Now, all these are built in a flexible manufacturing system equipment, which is there. Material handling, automated storage systems for large scale bulk storage, as well as small line buffer storage is handled. The tools are usually used in what is called as a carousels. The fixtures are kept there, it rotates, it takes out, the robot takes out the tool, fixes the tool, works. Then after the job is over, removes it and puts it back. A carousel is something like this circus thing, you see here, just keeps rotating and picking up whatever it wants. So an automated transport system is used to move parts and products from the storage system to the production systems. Using automated guided vehicle systems, conveyors in a variety of forms such as overhead, different types of conveyors, gantry and pick and place robots. Okay, so that is what is a flexible manufacturing system. Now we'll see what are all the, when you talk about a premise is nothing but an assumption. What are all the underlying factors, or what are all the assumptions that are there? What are all the uh, basic information you can see that are needed for a process design? So there are three generic planning premises in operations management. This is something we have to understand. One is make to stock. It is not made for any particular person, as we talked about in an automobile. Like a Maruti Swift car is not made for Anshaj. Anshaj may have bought a Maruti Swift with a certain variant, but when they are manufactured, when the product is being manufactured, similarly for any FMCG goods, white goods, even the continuous process goods, like in case of petroleum, cement, steel, the end user is not identified. It is made for us to stock, and from there it goes to the distribution system or the channels of distribution. It can be it can be directly a customer or through a wholesaler, distributor, whatever, and comes to the retails to the customer. So it is a make to stock, or more amenable for systems with fewer product varieties and higher production volumes, as in case of continuous and streamlined flow systems. Make to order. Organizations typically belong to manufacturer of high product variety use this planning. Most B2B, when you say B2B, is business to business products, or make to order. Like when I was making components, I don't make components to stock unless I'm giving it to a distributor or whatever. But even there, unless a distributor orders certain items to me, I don't produce. Similarly, like the various parts which goes into manufacturing of cars, the manufacturer of those parts which is supplying to the automobile manufacturer, he does not make and keep, unless he may do it in his spare time, but still he will ask for some kind of a master production schedule. You remember what we talked about MPS in product requirement from the manufacturer. So that if he says that, okay, next month I have to take my plant for a shutdown, so I would produce based on, but still it is based on the order or requirement from the next process, which is the customer. Then the last is assembled to order. Useful for intermittent flow systems catering to mid-volume and mid variety. This could be anything which is for most service industry. This comes under this assembled to order. I don't of course, except printing notes, of course, but then that is not a service industry. That is a primary bank which does that. But hospitals, restaurants, all kinds of job shops, printing presses, wherever you go, it is all assembled to order. Repair shops, whatever you have, banks, insurance, anything which you can think of where there is a direct customer facing, which comes under assembled to order. So the three planning premises for process design, to what kind of a process you need to design, whether it is a make to stock, make to order, or assemble to order. The whole thing is now put in a simple diagram here. If you see that from the complexity of operations management, finally, if you see, the indicators are from low variety, high variety. You see, low variety to high variety. In low variety, continuous flow systems mostly operate. Made to stock items operate. In intermittent flow, assemble to order, make to order, jumble flow systems. See, continuous flow, intermittent flow, jumble flow systems. Made to order, assemble to order, make to order. These are the three different types as you see here. This to this to this, and this to this here. There are more stages in production, greater variety in products, models, process routines, and technology choices. This, in short, is the thing. So that is in toto is what is the process design we discussed so far. So the highlights are that recapitulating volume, variety, and flow are the three significant influence on process design. What is a volume? What are all the varieties you handle? And what are the different process flows for which are required to get the end product? Process industries and mass production systems generally have a streamlined flow of products. Volumes very high, variety very low. Mid-volume, mid-variety manufacturing systems have intermittent flow. Capacity estimation is difficult in such systems because the ticket size or small this thing varies very much from a 0.25 HP to 100 HP, as we talked in the one example. Project organizations and customized manufacturing systems are jumbled flow. Capacity estimation and scheduling of jobs is extremely difficult. Therefore, operations management complexity is high in jumbled flow systems. A process product matrix depicts the relationship between the process flow and the volume of production that we saw in a very simple chart. Process design of service systems differs vastly from that of the manufacturing systems, mainly because in process design, it is a customer facing. So degree of customer contact and complexity and diversity of service offerings have a significant bearing on process design in service systems. Would say a general hospital probably has the maximum complexity which you can possibly think of. New technology, as I was telling you, I think a few sessions before, that Gangaram Hospital in Delhi, where I spent 6 days auditing. My God, you name the department in medicine, it is there. Each, including, in fact, that bariatric surgery section has a full flow, and they have special lifts taking patients up to that. Can you believe? They have special cots. It was quite funny, the way every furniture, everything was thing. Because when you talk about bariatric surgery, the patient who is coming in usually weighs about 150, 200 kgs. Right. And probably when he goes back, it'll be half the volume. But still, that's the they have to handle the special patients like that. Now, when you have a system which handles every single possible variation in a human being, to treat a human being, you can imagine the complexities which will be there in that system. Even for, like we talked about, an operation theater, where you can't say that you can do 10 operations per day. It could be only 2 operations today, but it could be 20 operations the next day. And in the Gangaram Hospital, I've seen 25 operations theater being controlled by a single, by a console, a planning department which sees what operations are going on their consoles, and how the moment one operation gets over, the entire process of cleaning and sterilizing and all that, and getting ready for the next, and allotting what type of operation for that particular OT, all that is planned. It's a very complex, and you cannot determine the uh, things very easily. Planning becomes extremely important in such kind of cases. Lastly, we saw that the whole thing can be again classified into three: made to stock, made to order, and assemble to order process. And that will again determine the type of process you need to you plan, and the facility which you need to plan, and then the layout which you need to plan for your operations. Volume, variety, and flow characteristics. Again, coming back to that, determine the complexity of operations management. By a careful design of the process, some of the complexities can be minimized. Obviously, you have to maximize throughput, minimize cost, and keeping the quality at the highest. And that is what is the challenge in operations management. Thank you. Okay, I have the screening is stopped.